Going to learn to understand application of functions. Now, applications can be quite challenging because it's really about just breaking the question down. So we'll go over a few. The first one, the cost of a taxi trip in a particular city is $1.75 up to and including 1 kilometre. After 1 kilometre, the passenger pays an additional 75 cents per kilometre. Find the function f which describes this method of payment and sketch the graph of y equals f of x. So the first part we need to be thinking about is what is my variables? So we know the variables is the x is the number of kilometers, c is the total cost. Now we can see that our graph is changing. That's why I put down the labels of identify the first equation, identify the second equation. So straight away it says here, the cost of a taxi trip in particular is 175 up to and including 1 kilometre. So this would be your cost of calling a taxi. Will cost as a fixed cost of $1.75 for 0 to 1k. So that will be our first equation. Y equals 1.75 is the constant amount. I've said 0, not equal to, because you even if you call a taxi, you're going to go at some amount. So x is greater than 0 and equal to or less than 1. The next part, it says after 1 kilometre, the passengers pay an additional 75 cents per kilometre. So 75 cents per k, that's going to be our gradient for our second equation. The gradient is m, so that means will be mk 0.75k. That's for domain of greater than 1. Now, the main thing we need to be thinking about with this is we need to know our starting point. The starting point is when we're at 1k, it's going to cost us 175. So we need to work backwards to find out the C value. So now I know that I'm going to use my point intercept form. So that is m in brackets x minus x2 equals y minus y2. I'm going to grab my x value of 1, y value of 1.75, and m of 0.75 and put it into my equation. I'm going to expand my bracket, and that gives me 0.75x, and 0.75 times negative 1 is negative 0.75, and when I take this over, it will be plus 1. So I've got my second equation right here. Now I'm going to create a piecewise. Again, we need to think about our conditions. We've got our conditions here and here. So it'll be f of x is equal to 1.75 for x is greater than 0 and greater than less than 1. And the second one is 0.75x plus 1 when x is greater than 1. The next thing is we're just going to graph that, and we can see this part should not be there. There we go. I'll take that out. So the first thing we need to know is it's a constant amount of $1.75 right here. And then at this point, it starts going up with a linear. Let's look at the next question. A rectangular sheet of metal has dimensions of 24 centimeters by 40 centimeters. 4 identical squares of side x centimeters are cut from the corners. An open tray is formed by folding up the sides. Write a rule for the volume V of the tray in terms of x. So the first thing we need to do before we even identify the length, width, and height is draw a picture. So I've drawn a picture. What I've done, and I'll get a laser, is we knew this here was going to be 40, but we're cutting out the length of x here and x here. So this actual length will be 40 minus 2x, and the height here will be x. On this side, the whole thing is 24 centimeters, but we're cutting out 2x's, so it's 24 take away 2x. So this tells me my length, my width, and my height. So I've just labeled them. Height is x, length is 40 minus 2x, and width is 24 minus 2x. Now, we need to write a rule. So if we write a rule for the volume of a prism, we're doing length times width times height. So that's all I'm doing with my equation. Now, the next part that I'm going to do is we need to identify the suitable domains. So there's a few things we need to be thinking about. Well, at the moment, we have zero volume. One of these has to be zero. We can't have negative volume, so we need to be mindful of that. So I'll look at the first one. I've got 0 equals 40 minus 2x. I get 40 to the other side, and I cancel out the negatives, so I get 2x equals 40. Here, I've got x equals 20. Now, straight away, if I put x equals 20 into this one right here, what you're going to notice, 2 times 20 is 40, 24 take away 40 is a negative. So my volume will be a negative. So I can't use this one. I'll look at the next one. That's 24 minus 2x. I then have to get x by itself. So I plus 2x to the other side, and then I divide 24 by 2, and I get x equals 2. This tells me the dimensions that I can. I'll be starting at 0 over here, and I'll be going all the way to 12. So my dimensions for my domain of volume will be x is greater than 0, and x is going to be greater, so less than 12. I've not put equal because we're not going to have volume of 0 because it doesn't make sense. We're talking about prism. Next question. The, the diagram shows the layout of an enclosure. The total perimeter is 180 meters. Find an expression for the area A of the enclosure in terms of x. State a suitable domain for the function and find the maximum possible area and the corresponding values of x and y. So this is where we can use some of our understanding, and I'm just going to grab color. So straight away here, if this here is red, so our y, then I can say this area here plus this area here, which is this here. I've grabbed that and took it down. So this also would be y. Likewise, if I grab this and take it out here, it's the same length as this side. So I know this whole side here can be the same as x. So that gives me 2x plus 2y is my total perimeter of 180. That's my first formula. I'll just erase those lines just so I've got space. Okay. The next part, it says create an equation for area. So the easiest way I found doing this was the following. I'll treat it as one whole. So click something else I didn't want. So I could do it as one whole rectangle, which means my area would just be x times y. So I will label this here as xy. But then I've got this extra part here. So I wanted to take this other rectangle. So to work out this, I've got 6 here. This length here would just be x minus 5. I've got x and I'm taking away 5. So it means to work out area, I'll just say this is 6, x take away 5. So that's what I've just done before. Area is equal to xy minus 6 in brackets x take away 5. Now, this is where we need to, I would go negative 6 times x is negative 6, and negative 6 times negative 5 is positive 30. Can I simplify it any further? No. The next part, it says rearrange the perimeter And that's what we're going to do, to substitute into the area formula. Because in the end, we've got two equations. We've got equation 1 and equation 2. So now we just need to work out the next part, because we are going to put y in y in, and we're going to then have an equation which says right here ax. We're wanting it to be a limit. So with perimeter, the first thing I would be doing here is I would be taking 2y to the other side and keeping it by itself. So I've got 2y is equal to 180 take away 2x, and then I'm going to divide by 2. That gives me y is equal to 90 minus x. Now I've got that, wherever I see my y, I can substitute it into my equation. So here, where I've got y, I've just replaced it with 90 minus x. So this is where I will then expand. So x times 90 is 90x, x times negative x is negative x squared. We are able to simplify. I've got 90x and take away 6x, which gives me 84x. I've just rewritten it in a certain form of just to make it easier for me. So I've got a is equal to negative x squared plus 84x plus 2. For the next part, we are going to be using the diagram to find a suitable domain. So here we can see we've got x, but we know x has to be here group 5 or more. That's the first part. So greater than 5. Likewise, y we've got here, which is 6. So y has to be greater than 6. Erase. Where's some space? Okay. So now we've done that. The next part, we already know what y is, or what y can be. So we know here y is going to be 90 minus x. I'm just going to substitute that in. Then I'm going to get x by itself. So here I took x to the other side. So I plus x, and the next part I'm taking 6. That gives me 84. So x is going to be less than 84. So that straight away gives me my domain for x. X is greater than 5 and x is less than 84. If you're thinking about the relationship between with area, then the next part that we need to do is we need to make sure we know the relationship of x to a. Now, that is where, if we're trying to find the maximum point, we're doing turning point. So one of the things with turning point is we can use the axis of symmetry. The axis of symmetry is negative b over 2a, which is part of the quadratic formula. B here is 84. We've got a here is negative. So I plug those in. I've got negative 84 over negative 2, and negatives cancel out. And I've got 42. I don't know why I wrote that twice. So now I've got this, I'm just going to need to grab this and substitute it into my formula to find out the maximum area, which is 1,794 meters squared.